Hi guys and welcome to today's Further Maths video on using box plots to describe and compare distributions. Further Maths, now there's a confusion if ever there was one, because in the United Kingdom, Further Maths is like Specialist Maths if you're over here in Australia. So if you are here expecting Further Maths from the United Kingdom, probably not, but that course is coming soon too. If you are over here in Australia and watching this, welcome. Really good to see you. Thanks for dropping by. We are going to look very much at box plots to be able to describe and compare distributions, because that's what this course is actually all about. Well, the first part. If you are new to my course, hi, welcome. I'm Darren, otherwise known as MaffsGuru, and it is really good to see you. If you're an old hand, hey, welcome back. Good to see you too. Now, I am one very small person trying to do a big job, and it's really good to have as many people subscribe and let me know you're watching as is humanly possible. So if you can do me the honor, please, of clicking, there is a red arrow over there, I would be deeply grateful. Thank you so much. It's not going to be a very long video because, to be perfectly honest with you, there's not a lot of new data in this. Further Maths over here is really structured to learn and be able to write about it. That's very much what this whole course is all about. And so we're going to take the learning that we've taken before about dot plots and sem plots, mean, range, interquartile range, 5-number summary, and knowing how to relate a box plot to the type of shape by its symmetrical or skewed, and then sort of use that to write or talk about stuff. There's only 3 examples, and the great thing is that all of those examples have been taken from the Cambridge Further Maths textbook. Thank you so much, Cambridge, for allowing me to use your examples. Greatly appreciated. Now, if you're not currently using the Cambridge Further book, don't worry about it. It's fine. This is universal. Maths is a language, but I have to say the Cambridge book is quite fantastic. So I'm going to deal with 3 examples. There are questions and there are their standard responses. And I just want to talk to you about why their responses are structured the way they are. Now, if you have a summary book, don't worry about it. That's brilliant. You can cut out the response by downloading all of this stuff from MaffsGuru.com. My PDFs are all there, and you can annotate all over it. You can cut it out, stick it in, and write whatever you want to do. Further Maths over here is great because you can scaffold those answers. So here's my first example. Describe the distribution represented by the box plot in terms of, now interestingly, they're telling you what they want you to write about. In terms of shape, in terms of center, and spread, and give appropriate values. So there's 4 things there you would have to put in your answer to get the marks. You would need to talk about the shape, whether it's symmetrical or whether it's positively skewed or negatively skewed. Talk about the center, where is the medium, and the spread of the data, so the range or the interquartile range. Now, as I say, Cambridge have given a sort of sample response, and I love the fact that they do that because it makes life easier for us. So let's just see. One possible description, and again, this is just one. The distribution is positively skewed with no outliers. So have I talked about my shape? Tick. There we go. I have a positive skew, and I've mentioned the fact there are no outliers. It's really important for all sorts of these diagrams to mention whether there are outliers or not. Full stop. Short and to the point. I'm not writing your life story. I'm not writing a mathematical, sort of essay. It is literally the distribution is positively skewed with no outliers. Full stop. The distribution is centered at 10. Good. So now I've shown the examiner. Do I know what it means by center? Yes, because the center is that line there. It's the median. That is the center of my data. Yes, and they've even put as their sample response the idea that you are saying I'm using the median as my center. Now we're talking about the spread of the distribution as measured by the IQR. Now again, the spread can be written in 2 different ways, and the box plot can actually give you both the interquartile range, which is the spread of the middle 50%, and the range. And what they've done is they said, okay, I'm clever. They're hedging their bets. Why not give 2 measures of spread? And they've said the interquartile range is 16. And if you remember, how do we work out the interquartile range? It's the upper quartile minus the lower quartile. My upper quartile seems to be 21. My lower quartile seems to be 5. And when I subtract those, gives me 16. But I've gone on, or they've gone on to suggest, well, why don't we talk about the range as well? Because the range is the biggest value, which is 45, minus the smallest value of 0. Now, as a response, that's covered everything they've asked me to do. Maybe a little bit more, but it's definitely covered what they've asked me to do. We've now got a second example. That last one didn't have any outliers. All right, but that was great. We still talked about spread and shape and outliers, even though there weren't any outliers, and center. So again, this one now, same question. It's saying, talk about the shape, the outliers, the center, and the spread, and give appropriate values. They want to know you can read this stuff. Okay, and again, what is the sample response they've come up with? Right, one might be, again, talk about the distribution shape. It is symmetric. How do we know that? Well, when we ignore these outliers here, I can see that my data seems to be, actually that graph is in a really stupid place, so try that one again. Here is my center point, and it would appear that my sections are split roughly equal. They're not identically equal, but they're roughly the same width for each of them. So I can now turn around and say, as the question says, my distribution is symmetric with outliers. Okay, so either we're going to say in the response they have outliers or there's no outliers. We're not going to talk about outliers for this moment in time. And then we're going to go on and say, what about the center? Okay, full stop. My distribution is centered at 41. How do we know that? We read it off from my median line. And again, comma, the median value. We've said we know what the median is. The examiner now is really, really happy. The spread of the distribution as measured by the IQR, do you see it's the same language? All they're doing is changing the important words to fit. The spread of the distribution as measured by the IQR is 5.5. All they've done is they've looked at this upper quartile, they've looked at the lower quartile, they've subtracted them, and they've put the actual value in. And likewise, they've done the same for the range. Now again, the range is that biggest value there, minus that smallest value. Remember that we include the outliers as part of my range. And I've just said, the value of the IQR is bang. The value of the range is bang. Last thing we've done is we've made specific mention now of the fact that we know there are 4 outliers. We've actually counted the number of outliers, and we said these outliers are at 10, 15, 20, and 25. So do you see what I mean about your summary book? Take out the general idea of, or sort of cut out one of these responses, and then just highlight the words or the numbers you have to change, and you're never going to go wrong. Third example. All right, again, this parallel box plot. So now we've got 2 box plots. Previously, we were talking about just describing information for one box plot. That's fine, that's not a problem. But in many cases in further maths, you've got to then explain or compare 2 of them. No different, same idea. So there we go. We've obviously got information about age at marriage in years, and we've got a woman or women and men data in terms of a box plot. Compare the 2 distributions. Compare the 2 distributions in terms of shape, center, and spread, and give appropriate values at a level of accuracy that can be read from the plot. Okay, so what they're saying is just be careful. Try and make it as accurate as you can, but the examiners realize that maybe it might be 1 or 2 out. So here is the suggested response. The distributions of age at marriage are positively skewed for both men and women. That's fairly obvious because those sections are shorter at the very beginning and much, much longer in my tail. But again, notice now that they're not talking about the distribution is positively skewed for men, full stop. The distribution is positively skewed for women, full stop. We've combined it. We're saying we know that. There are no outliers. Again, we can see that. There are no outliers on any of my diagrams. The median age at marriage is higher for men. So we're now comparing. We're going, okay, let's look at the center. What do we notice about the center? The center for the men is higher than the center for the women. And we've stated that. The median height at marriage is higher for men. And we've stated what it is, 23 years, than women, 21 years. So I'm giving some physical data about my center. The IQR is also greater for men, 12 years. Now somewhere they've worked out the IQR for men and the IQR for women. And again, the IQR for men is greater than women. And in brackets, we've given the information. Finally, we're talking about the range. The ranges of age at marriage is also greater for men than women. So we're actually, to be perfectly honest with you, stating the flipping obvious. We're literally just stating the obvious. We're going through, and as I've said before, they're looking at center, shape, spread with actual values. But when you're comparing, really you're just turning around saying the range is greater for men. The IQR is greater for men than women, and you're giving that information. The final part of the question says, comment on how the age of the men when first married compares to that of the women. What's my response for this group of men and women? The men on average married later, and the age at which they first married was more variable. That's all read from that diagram, okay? The men and women on average married later. So on average, what do we use that for? Maybe the median. We seem to think that men married slightly later, 23 years as opposed to 21 years. And the age at which they first married was more variable. How do we know that? The spread of that IQR. So we've taken it one step further and we're saying, hold on a moment, we know what spread means. We're looking at the idea of comparing that middle-aged men do later, and they actually seem to have a much bigger spread. This is something you practice with questions and questions and more questions. But ladies and gentlemen, I'm actually finished this video. Thank you so much for watching. It is the end. If you haven't already done so, a subscribe button will appear over there in just a moment. And just below that is a little box with videos along this. A short video, 3 examples talking about comparing and extracting data which we can take from a scaffold. It's great seeing you. Thank you very much for dropping by. Hopefully I'll see you again. Take care. MaffsGuru out.